So if a mole is a way we count things, and ultimately the way we weigh things to figure out how many parts there are so that we can relate them to each other. We go to the chart. If they're pure elements, we just take the value of their atomic mass, their average atomic mass, and that tells us how heavy one mole, or one group of 6.02 times 10 to the 23rd parts, is. But what if it's a compound? Because a lot of times in reactions we're dealing with compounds, with molecules and ionic compounds with formula units. So let's talk a little bit about how you calculate the molar mass of a compound. Just adding one more step here, one more little layer. So if we're trying to figure out the mass of one mole and why that's going to become important, will become clear. For a compound, what we have to do is just add up everything that's there in terms of its mass and the amount of each element. All right, so it's add up the mass of each element, but make sure you time each element by its amount in the compound, in the formula. So for example, water. The formula for water is H2O. That means there's 2 hydrogens, 1 oxygen. Well, if we go to the periodic chart, hydrogen has a mass of 1.0, 1.0001. And oxygen has a mass of 15.9995, so I was rounded up to 16.0, just makes the math easy. So 2 hydrogens at 1 apiece and 1 oxygen weighing 16 grams. Well, when I add that all up, I get 18 grams in every 1 mole of water. So just to give you a perspective, here's a water bottle. Okay. 500 milliliters of water, well, the density of water is about 1 gram per milliliter, so let's just say approximately this weighs 500 grams as well, because it's water, not counting the bottle itself. Okay? So just the water in this bottle weighing 500 grams. How many moles of water is that? Well, we divide by 18. If there's 1 mole is 18 grams, dividing by the 18 grams tells us that this container has 27.8 moles of water in it. Just to give you a perspective, how many molecules of water is that in this water bottle? Well, using our other conversion factor of 6.02 times 10 to the 23rd molecules in every mole, because that's the amount, that's 602 heptillion, it turns out that this water bottle is holding 1.67 times 10 to the 25th molecules of water. All right, let's see. Heptillion, octillion. So that's 16.7 octillion. Octillion. Can you even get your head around that number? Huge number of molecules. Why? Because each one of them is so tiny. Would I be able to count 16.7 octillion water molecules? No, I can't even see them. But I can know there's that many because of the mass, and because I know that water has a molar mass of 18 grams. Every mole weighs 18 grams. So if I know the weight of the water in the container, I can do a little bit of math and figure that out. Isn't that cool?